right, for this one, this is stoichiometry and empirical formula because I did not include empirical formula on my moles one. I'm going to show you here what you need to know for the regions. Okay, we have certainly done more of this ourselves in our class. Okay, but I'm going to show you what you need to know for the regions because that is what we are currently preparing for. All right, empirical formula is the most reduced form. Okay, so if I gave you something like C6H12O6 and said, what's the empirical formula? You would reduce it down. You've got to reduce the whole thing. And it would be CH2O. That's its empirical formula. That's not what the molecule of glucose actually looks like. It's just telling you that the ratio of carbons to hydrogens to oxygens is 1 to 2 to 1. Okay? Something like CH4, this is methane. This is both an empirical and a molecular formula because the the molecule of methane actually looks like CH4. There's 1 carbon and 4 hydrogens. It's also the lowest whole number ratio. Okay? So we're going to continue with this problem. Find the empirical formula of a substance that's 30% iron and 20% oxygen. When you get these percentages, you need to put them into grams. Assume you have 100 grams, therefore you've got 30 grams of iron and 70 grams of oxygen. Next thing you need to do is turn them into moles, okay? Why? Why do we need to use moles? Because these numbers here, this 4, this 6, this 12, those are all moles. They're how many, okay? If I have a mole of glucose, I have 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen atoms, okay? So I can't use grams. I've got to figure out how many atoms of iron do I have? How many moles of iron do I have? And the same for oxygen, okay? So, first and foremost, iron. Iron weighs 56 grams per mole. So I need to convert 30 grams into moles, okay? If 1 mole weighs 56 grams, it should be less than 1 mole, okay? I'm looking for moles. I'm starting with 30 grams, and I know that 56 grams is 1 mole. Grams cancel. If I have a calculator handy, I'm looking at 30 divided by 56, and I end up with about 0.54 moles of iron. Do the same thing with oxygen. How many moles of oxygen do I have? I have 70 grams of oxygen. I think this might be backwards, but that's okay. 70 grams of oxygen. I'm looking at 1 mole of oxygen weighs 16 grams. Okay, so this should be less than 1 mole. 70 divided by 16. And I'm looking, excuse me, there's 1 mole. Grams cancel, and I have 4.38 moles of oxygen. And I do have these backwards, but that's okay. So this isn't actually going to be a real compound, but you get the same idea. Now I have the number of moles of each. Write them as subscripts. It should look funny. Okay? It should look funny. You don't normally see decimals as subscripts. That's okay. Find the lowest whole number ratio by dividing by the smallest number. And then I'm going to end up with FE1, because 0.54 divided by 0.54 is 1.08. Like I said, that's not a real thing. I flipped them in this example. If for some reason you ended up with something like FE1, let's say 1.5, it'll be very close to 1.5, like 1.45 to 1.55. The Regents plans their numbers accordingly, unlike I did apparently in this problem. If you end up with a 1.5, you need a whole number ratio. That means you have 1 iron for every 1.5 oxygen. Just multiply it by 2. Okay? If you can multiply it by 2, you end up with Fe2O3. Okay? That is a lowest whole number ratio. That is your empirical formula. okay? That's how you do empirical formulas. A couple steps. Take the grams that you're given, convert them to moles. Write them as subscripts, find the lowest whole number ratio, okay? Stoichiometry. The only stoichiometry you need to know for this Regents exam is moles to moles, okay? You only need to know moles to moles. Okay, sorry. Moles to moles. So that's just changing your recipe, okay? So for this case, make sure you have a balanced equation first and foremost. Your equation must be balanced. This is like making cookies. I'm starting with a mole of nitrogen and 3 moles of hydrogen, and I am ending up with 2 moles of ammonia. NH3 is ammonia, okay? So all you have to be able to do is do moles to moles. So right now I'm going to say I'm going to start with something easier. So ignore this for right now. We are going to do moles to moles. So if I start with 1 mole of nitrogen, how many moles of ammonia am I going to produce? You use the molar ratio. What that means is you need to use these coefficients. Remember, there's a 1 in front of N2. Here's your 3, and here's your 2. I have a 1 to 2 ratio with nitrogen to ammonia. So if I have 1 mole of nitrogen, I'm going to end up with 2 moles of ammonia, assuming I have enough of everything else. And in these cases, you will be able to assume that, okay? If I had 2 moles of nitrogen, okay? So I'm not starting with 1 mole anymore. I'm starting with 2. Well, if I started with 2 moles of nitrogen, I have to change everything else. I would need 6 moles of hydrogen, and I would produce 4 moles of ammonia. That's what I do when I bake for you. Okay, if I have a recipe that makes a dozen cookies, but I have 2 dozen of you in class, I need to double it. I don't just double the chocolate chips. I double everything. It's the same thing. This is a recipe. This is how a chemical engineer would make ammonia. Okay, so if I said I don't have 2 moles of nitrogen, perhaps I have 3. No, I don't want to do something like that. Let's erase these and make it a little bit more complicated. Let's say I don't have 3 moles of hydrogen, I have 10 moles of hydrogen. How many moles of ammonia am I going to produce? Well, you could figure that out in a number of ways. I'm going to show you 2 ways to do it, okay? The first way is a proportion. I know that I have a 3 to 2 ratio. I don't have 3 hydrogens anymore, I have 10 hydrogens. How many ammonias will I produce? Just keep your hydrogens on top and ammonia's on the bottom. Another way that you could do this, let me just move this little recording guy, is with our awesome fence method. How many moles of ammonia given 10 moles of hydrogen? Well, I know that it's 3 hydrogens to 2 ammonias. What cancels? Hydrogens go away. It's 20 divided by 3, which is about 6.7 moles. Okay? 6.7 moles of NH3. The hardest part of stoichiometry as far as the reagents is concerned is remembering to use the ratios. Okay? Make sure you use your molar ratios. That's a T. Make sure you use those molar ratios, okay, in order to figure that out. Let's do one more. I'm going to erase this guy. Let's say I don't have 3 moles of hydrogen, but I only have 1 mole of hydrogen. Okay? I have 1 mole of hydrogen. I can go down just like I go back up. I can have a recipe or third a recipe. So I essentially divided that by 3. You can also do these in your head, okay? This would be 2/3. You want me to show you? I will happily show you. It's the same ratio here. You can start with this same ratio, but I'm given 1 mole of hydrogen, and I'm looking for X of NH3. How many moles of ammonia? Same thing here. It's the same setup. Looking for moles of ammonia. Same molar ratio. This does not change. This is the same. But I'm starting with 1 hydrogen here instead, and you can see that my answer would therefore be 2/3. Okay? Moles to moles are really easy. Just don't forget about that molar ratio.